To solve this system of equation by substitution, one of our variables must be isolated, or in other words, kept by itself on one side of the equation. In this system of equation, I would choose negative a to be isolated. The reason is the coefficient of a is negative 1. As a general rule, if a coefficient of a variable is 1 or negative 1, we choose to isolate this variable because it will make our life easier. So if we choose a to isolate on second equation, we have to get rid of everything on left side of the equation except a. To do it, we simply subtract 6b from both sides of the equation. So we have negative a is equal to negative 6b minus 13. To get a by itself, we have to divide both sides of the equation by negative 1. So we have a is equal to 6b plus 13. Since you know what a is, you can substitute a on one of the equations with 6b plus 13. So let's choose first equation. In that equation, we will substitute 6b plus 13 instead of a. That will give us 3 times 6b plus 13 plus 7b is equal to negative 11. When we use distribution property, we have 18b plus 39 plus 7b is equal to negative 11. 18b plus 7b is 25b plus 39 is equal to negative 11. To get rid of 39, we subtract 39 from both sides of the equation. So we have 25b is equal to 50, negative 50. Then finally, we divide both sides of the equation by 25 to get b by itself. So b is equal to negative 2. To find a, instead of plugging a negative 2 in one of the b's of equations, I would choose to use this equation that we already isolated a, because it will make your life easier. The only thing you should do is plug a negative 2 instead of b on this equation. So let's do it. We do it. A becomes 6 times negative 2 plus 13. If we simplify further, 6 times negative 2 gives us negative 12 plus 13, and a becomes 1. And since we know a and b, we can write our solution sets as 1 and negative 2.